Hi guys, I'm Purushothaman Srikanth. Today we'll discuss about lazy evaluation in Apache Spark. Apache Spark is a wonderfully built data processing framework that can handle both batch data and streaming data. Lazy evaluation is one of the features of Apache Spark. So for folks who have already worked with frameworks like TensorFlow, you might have heard this term eager evaluation. Before we get into lazy evaluation, let's try to understand what are the different types of operators in Spark. There are actually two types. One is transformation, the other one is action. In the case of transformation, you are working on an RDD or a data frame or a data set. You're trying to do some transformation, some kind of change on the data that is sitting inside those RDDs, and you're trying to create a new RDD out of it. So that's what a transformation does. For example, map, filter, sorting, all these methods are transformations. Whereas an action is something that will force the system to get the data. For example, print, collect, show. So data that is sitting inside an RDD, you don't want it to stay there, you want it to have a look at it, or you want it to print it, you want it to store it somewhere, maybe in a target table or in a directory. So that's when action comes into picture. So lazy evaluation is a technique where you are forcing the system not to execute anything. Meaning, when you run those transformations, you try to load the data, you try to do a filter, you try to do a map, nothing is going to happen. Only when you call an action, that's when all these steps are getting executed. Okay, let's take an example. Where let's assume we have 1 lakh records and let's assume it's 1 GB. Now, we are going to assume that Spark doesn't use lazy evaluation, and I've written some Scala code here. So that in the first step, I'm trying to read that data from a text file. Then I'm storing that in a RDD named as RDD1. In the second step, I am trying to run a map function on top of this data. And in the third step, I'm trying to do a filter on top of this data. So in the last step, I'm calling some kind of an action. So this will print all the records that are there in the RDD. Until I call this action, all these steps will not get executed. Okay, what will really happen then? A DAG is getting created. DAG stands for Directed Acyclic Graph. So here, all the different operations that we are going to perform, all the transformations, they take their positions. Nothing is going to happen. Is this the correct way to do it? No. There is a better way to run this code. That's where the Spark Catalyst comes into picture. So the Spark Catalyst needs to know how the DAG is being structured. So from where the data is being stored, where the data is going to be down or shown, if that path is visible to the Spark Catalyst, it can make a much better path maybe, right? So here, the first step remains same. In the second step, we are not using the map. Instead, we are using the filter and then we are calling the map. Okay, why is it done? So the normal practice is to minimize the amount of data that is being moved between executors. You wanted to only work on the necessary data or the data that is of high importance or the data that you're going to use in the result. When we talk in terms of data, we are not going to talk about 1 gigabyte or 2 gigabyte. In the industry setting, it will be terabytes and petabytes of data. So for those scenarios, you wanted to minimize the data that has been shuffled or minimize the data that has been involved in some kind of transformation, transaction or whatever it is. So the Spark Catalyst will actually move the filter up and move the map down and then call the action. In order for the Spark Catalyst to do this, it needs to move the picture. When in the case of eager evaluation, all these steps will get executed in the order that you have mentioned, and Spark, the Catalyst doesn't have control over determining what will be the best thing to do. In the case of lazy evaluation, the Spark Catalyst can actually modify your code, meaning not the actual code, but the way in which your code is going to run. So this is how the optimized new code will look when you actually run Spark with lazy evaluation. There are a lot of perks, and I'm going to discuss a few here. Number one is you are going to minimize the number of data or the amount of data that is being moved between your disk, which is HDFS, or it can be S3 or any other storage system, from there to your memory. And inside your memory, you're going to reduce the amount of data that is being moved. The next thing is all the intermediate RDDs that we see here, they can be minimized. When you call an action, you are only going to have the data inside the final RDD, or let's say I wanted to show the data, so the data will be sitting inside the previous RDD, which is RDD3 here in this case, and all the intermediate RDDs are no longer in the picture, which means your memory is used in a much better way. It's more efficient. Obviously, the code becomes efficient because of that. And the last thing is you are making use of one of the most powerful code optimization engine, which is Spark Catalyst. So when you are dealing with terabytes of data, things might become a little easier. And not just that, as a developer, when you start building your ETL pipeline, where you're going to fetch data from somewhere, store it somewhere. In between, you will do some ETL transformations on the data. Every time you call a filter, every time you call a map, you don't want your system to get blocked, because the system needs to look into all the records, perform the map function on top of that record, and let's say you have a petabyte of data. That may take you 5 to 10 minutes, or if your system or your server is little slow, it might take even more. You can skip all those steps, and only when you call an action that is as a function that is going to force the system to get the data, or show the data, or dump the data, that's when these transformations are happening. It's like doing all the process once instead of repeatedly doing it many times. I hope you guys loved it. Happy learning. See you.